But they didn't get here. If I get it,
All right, here we go. Practice mini test. Can everyone see this? All right, number one. Shh. In thermodynamics, the universe is defined as the system plus its surroundings. Now, listen up. Shh. If we had lots of time, I would have you go through the book and find this. And you can go through the book and really read more about this. But number one, I'm going to tell you that this is true. There's a system, there's a surroundings. Jay? Kimberly? And let's say that you're talking about someone sweating, okay? When someone sweats, the system is that layer on your skin that has the cold water, okay? Now, when that sweat evaporates, the surroundings get cooler, okay? So what's getting cooler is all that area around your skin, and that's why you cool off, okay? So if you read more about thermodynamics, you will see that this is certainly a true statement right here, okay? Number two, potential energy, all right, is the energy of motion. This is old news. David Howard, is potential energy energy of motion? True or false? False. False. Potential energy is, Aubrey, you got it. What did you call that? Stored energy. And guess where it's stored? For chemistry, it's stored in chemical bonds, okay? If you were to break apart a water molecule, you would release energy, okay? I'm sorry, it would require energy. It would require energy to break that bond, and it would release energy as new bonds are formed, okay? What is the energy of motion, guys? What's that energy called? Demetrius, what's the energy of motion? You learned this way back when. It starts with a K. Kinetic. Very good, Demetrius. Okay. All right. Shh. Number three. During a chemical reaction, the chemical potential energy of a substance is released as heat. That's what we've been talking about. We've been talking about heat energy. Okay. And we can also call this enthalpy. So write that down. This is a true statement. And we can call that heat energy enthalpy. Okay? Write that down and write this down. This little practice guide is going to be really useful for you, okay? Because you're going to have some extra notes on it in addition to having the answers to these problems worked out. Yes, number four, the law of conservation energy states that energy is neither created nor destroyed. Jocelyn, what do you think about that? True or false?
That's Charles. True.
That's why it's better when some people go to the bathroom, you know. Okay, true. Number five. That's right, Jocelyn. Okay. Number five, the symbol C. Some people are good at knowing their laws, though, you know. Okay. Symbol C is used to represent heat. This is a little tricky. Let's go with Lamar. False. And you know what? Lamar learned that earlier because I called on him and I said, shh. I said, what represents specific heat? And he told me Q, but then we corrected it with one another. What is the, so I talked over your answer. What's the right answer, Lamar? False. False, and why? What can I change about this statement to make it correct? Very good. That C could be a Q. What does C represent? C is specific heat. Don't you think it would help if we write that down right here? All right. Now, numero 6. The symbol delta S is used to represent change in enthalpy. Well, you know what, guys? I taught you delta S yesterday, but I didn't tell you that symbol. Let me write this down for you. All right. Delta. Which word? Why don't you like the word enthalpy? It sounds weird to say enthalpy 3 times in a row. You sounded cool saying that, okay? That was very cool, okay? Delta S is entropy. Everyone say entropy. Entropy. Okay? Delta S is entropy change. What does entropy mean?
Probably the opposite of entropy.
No, it's not the opposite. They're actually, you need both of them. Randomness and disorder. Nature tends toward what? Increase in disorder or decrease in disorder?
Decrease. Increase.
Increase. Yes, we missed you yesterday, Aubrey, but when you rake up a pile of leaves, Aubrey, does it tend to make itself neater or messier if you leave it alone? Messier. Things get messier if we don't tend to them, right? What happens to your room by the end of the week if you haven't done much to work on it? It gets messier. Okay? All right? Shh. Now, is everyone writing this down about entropy? This is all very important. Now, I have something else I want you to write down about enthalpy. Which word do you like better, entropy or enthalpy? Entropy sounds a little bit like a trophy. You know, that's a good thing, right? Okay. Shh. All right. Oh, one more thing right here. What does nature want? A positive or a negative delta S value? Positive. Positive delta S value is the more natural order of things, right? Okay. Now, enthalpy. Enthalpy means heat energy, right, Eric? All right. Nature tends toward. Now, this is like the ball rolling up the hill or down the hill. What does the ball want to do? Roll up or down the hill? Down. Down. We want to go down in energy. Nature tends toward lower enthalpy and a X, which means exothermic reactions. Did you know that exothermic reactions always have a negative value? So write that down. We tend to go toward negative enthalpies. Right, Lamar? Which you counting? Which, are you counting something? All right. Yes, I haven't addressed it yet. Okay, thanks. Is everyone writing this down? Writing it down?